Okay, Wildcats, today we're looking at 8.3, graphing more complicated rational functions. Assignment tutorial. Enter the domain of the function using an inequality set notation and interval notation. For any x value excluded from the domain, select whether the function's graph has a vertical asymptote or a hole at that x value. Using a graphing calculator to check your answer. So we have f of x equals x plus 3 divided by x plus 5. So step 1, we're going to set the denominator of the function equal to 0. And then we're going to solve. So we have x plus 5 equal to 0. So we're going to subtract 5 from both sides. So then x equals negative 5. The function is undefined at x equals negative 5, so the graph has a vertical asymptote at x equals negative 5. Complete this. Step 2. Complete the domain in each form. In inequality notation, since it's undefined at negative 5, x is less than negative 5 or x is greater than negative 5. In set notation, again, since x is undefined at negative 5, it's x such that x does not equal negative 5. In interval notation, it's negative infinity to negative 5, not including negative 5, or not including negative 5 to infinity. All right, go ahead and finish up question 1. All right, let's take a look at question 2. Enter the domain of the function using an inequality set notation and interval notation. For any x value excluded from the domain, select whether the function's graph has a vertical asymptote or a hole at the x value. Using a graphing calculator to check your answer. Step 1. We're going to factor the denominator of the function. Set it equal to 0 and solve. So we know 2 parentheses equal to 0. Now we know x and x makes x squared. Okay. Now we ask yourself, what do you multiply to give you a positive 2 and combine to be negative 3? Well, negative 1 times negative 2 is positive 2. Negative 1 minus 2 equals negative 3. So our factors are x minus 1, x minus 2. Now we need to set each of those equal to 0, so x minus 1 equal to 0, x minus 2 equal to 0. And solve. So add 1 to both sides. Add 2 to both sides. So the function is undefined at x equals 1 and x equals 2. Step 2, complete the domain of each form. In inequality notation, since, again, it's undefined at 1 and 2, x is less than 1, or x is greater than 1 but less than 2, or x is greater than 2. In set notation, it's x such that x does not equal 1 and x does not equal 2. In interval notation, it's negative infinity to 1, not including 1, or not including 1 to not including 2, or not including 2 to infinity. All right, go ahead and finish up step 2. All right, step 3, factor the numerator and the denominator to find the whole. Okay, so 2 parentheses, x and x. Now you ask yourself, what do you multiply to give you negative 5 and combine to be a positive 4? Well, negative 1 times positive 5 is negative 5. Negative 1 plus 5 equals 4. So our factors are x minus 1, x plus 5. Okay, so 2 parentheses, x and x. Now you ask yourself, well, what multiplies to give you positive 2 combined to be negative 3? We already done that. We know it's x minus 1, x minus 2. Now to find the whole, we look for what divides and becomes 1. This divides and becomes 1. So we know to find the whole, we're going to set x minus 1 equal to 0. Okay, so we're going to add 1 to both sides. So x equals 1 is the whole. Okay, so the graph has a hole at x equals 1. Okay, now we set the denominator equal to 0, so x minus 2 equal to 0. Add 2 to both sides. X equals 2. And that's your vertical asymptote. Okay? So the graph has a hole at x equals 1 and a vertical asymptote at x equals 2. Right. All right, question 3 of 15. Divide the numerator by the denominator to write the function in the form f of x equals quotient plus remainder divided by divisor. And determine the function's end behavior, then enter the range using inequality, set notation, interval notation. Okay, so we need to divide, step 1. So I'm going to go ahead and put a 1 here. Now you ask yourself, what do you multiply 1x by to give you 4x? The answer to that is 4. Now, this is the quotient. So that's 4. Plus, we need to find the remainder. So now we multiply 4 times x is 4x. 4 times negative 2 is negative 8. But we subtract. When we subtract a negative, it becomes positive. That cancels. 1 plus 8 is 9. And 9 is your remainder. Okay, so that's 9 divided by the divisor, which is this, which is 1x minus 2. Or we can just write x minus 2. Okay? All right. Step 3. Enter the range. The range is less than 4 or greater than 4, which we get that from the remainder. In set notation, it's y such that y does not equal 4, so y does not equal the remainder 4. In interval notation, it's negative infinity to 4, not including 4, or not including 4 to infinity. All right? All right, question 4.15. Divide the numerator by the denominator to write the function in the form f of x equals quotient plus remainder divided by divisor. And determine the function's end behavior, then enter the range using inequality set notation, interval notation. F of x equals x divided by x minus 5 times x plus 5. Step 1, divide. Now, before we divide, I know I've been wearing a mask all year long, but because I'm safely in a room all by myself, I can finally disclose what my face looks like, and I will do that now. All right. Step 1, divide. So we ask ourselves, what do we multiply x squared by to give us 0x squared? The answer to that is 0. All right. Now, that's our remainder. Oh, I'm sorry, that's our quotient. Okay. So that's 0 plus. Now we need to find the remainder. So 0 times x squared is 0 x squared. 0 times 1x is 0x. 0 times negative 20 is 0. And we subtract. Well, that's just 0. 1x minus 0 is 1x. minus, and really just plus 0. Okay, so that's your remainder. Okay, so the remainder, which we can just write as x divided by the divisor, is this, but I believe they're going to want this as the divisor for your answer. Okay, so parentheses x minus 5, excuse me, x plus 5. Okay. All right. Enter the range. In inequality notation, it's basically from negative infinity to infinity. In set notation, it's y such that it's negative infinity to positive infinity. In interval notation, it's from negative infinity to positive infinity. All right. Question 5 of 15. Divide the numerator by the denominator to write the function in the form f of x equals quotient plus remainder. Okay. And determine the function and behavior, then enter the range using inequality set notation and interval notation. So you have f of x equals x squared minus 6x plus 8. Now, we need to divide. Okay, so we divide x minus 1 into x squared minus 6x plus 8. Okay, so you ask yourself, what do you multiply x by to give you x squared? Well, the answer to that is x. So 1x is right here. Put a 1 right here. 1x times 1x is 1x squared. Okay, 1x times negative 1 is negative 1x. And we subtract. Subtract positive. That cancels. Negative 6x and 1x is negative 5x plus 8. Now you ask yourself, well, what do you multiply 1x by the, excuse me, give you negative 5x? Yeah, excuse me, negative 5x. Okay, so negative 5 times 1 is negative 5x. Negative 5 times negative 1 is a positive 5. And I wrote the plus, but you don't want to do that, and I'll show you why here in a second. Okay, you just want to leave the positive 5 without the plus sign. Okay, because, and the reason why you don't want to put the plus sign is because you have to subtract. When you subtract this, it becomes positive, and when you subtract a positive, it becomes a minus. So you want to leave that space open so you can put the minus. Those cancel. 8 minus 5 is 3. So the quotient is x minus 5. Okay, the remainder is 3 divided by the divisor, which is x minus 1. All right, go ahead and finish up step 2. All right. Step 3, using the graphing calculator to find and enter the range. Okay, so to explain how you get these decimal numbers, we need to go back and we need to graph this. And I recommend graphing it in Desmos. Okay. All right, so I'm going to press the division symbol, and I'm going to type in x squared minus 6x plus 8 divided by x minus 1. Okay. You can move the graph here, and then if you click right there and right here, if you round this to negative 0.54 and leave that as negative 7.46, that's where you get the values. Okay. that's where you're going to get the negative 7.46 and the negative 0.454 in the range. Okay, so inequality notation, y is less than negative 7.46 or y is greater than negative 0.54. In set notation, it's y such that y is excuse me, less than negative 7.46 or y is greater than negative 0.54. Interval notation is negative infinity, negative 7.46, not including that number, or not including negative 0.54 to infinity. Okay? All right. Question 6 of 15. Divide the numerator by the denominator to write the function in the form of f of x equals quotient plus remainder divided by divisor, and determine the function's end behavior. Then enter the range using inequality notation, set notation, and interval notation. So f of x equals f of x squared, or 4x squared minus 1 divided by x squared plus 1x minus 2. And we're going to divide. Now, you'll notice that this is 4x squared minus 1, but I've added the 0x because this has to have x squared, x, and a constant, and this has to have the x squared and x and a constant. Okay? So put a 1 here. Now you ask yourself, what do you multiply 1x squared to give you 4x squared? The answer to that is 4. Okay? Which is our quotient. Okay? Now we need to find our remainder. So 4 times x squared is 4x squared. 4 times 1x is 4x. 4 times negative 2 is a negative 8. And we subtract. Minus, minus, plus. That cancels. You're left with negative 4x, excuse me, plus 7. Okay? So that is your remainder. Okay? So then that's... Now, I would normally every time you put a plus and then the minus 4, but I think you're filling in the box. So I think in the answer, you're going to put negative 4x plus 7 divided by the divisor, which is here. X squared plus x minus 2. Okay? All right. So again, to find these values, excuse me, we're going to go to Desmos. If I can find Desmos. All right, and I can actually, to save myself time, I can just delete the numerator, delete the denominator, and then I'm going to graph this. So 4x squared minus 1 divided by x squared plus x minus 2. All right, and what you're going to need to do is zoom out. Okay. And then you want this point right here. Okay, you'll notice that's where you get the 0.51. And I believe if you click there, you'll get the 3.491. Okay. So in inequality notation, it's y less than 0.51 or y is greater than 3.49. Set notation is y such that y is less than 0.51 or y is greater than 3.49. In interval notation, it's negative infinity to 0.51, not including 0.51, or not including 3.5 or 9 to infinity. All right, let's take a look at question number 7. Okay, select the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graph slant asymptote by dividing the numerator. Excuse me. Now, the numerator by the denominator. Also state the function's domain and range using inequality, set notation, interval notation. If your graph indicates that the function has a maximum or minimum value, use a graphing calculator to find those values to the nearest hundredth when finding the range. Okay, so f of x equals x minus 2 divided by x plus 2. Step 1, find the vertical asymptote by setting the denominator equal to 0. Okay, so we said x plus 2 equal to 0 and solve. So we subtract 2 from both sides, so x equals negative 2. Okay. So there is one vertical asymptote at x equals negative 2. Step 2, divide. So we're going to put a 1 here and a 1 here. You ask yourself, what do you multiply 1x by to give you 1x? The answer to that is 1. Since the numerator and denominator have the same degree and the leading coefficient of each is 1, so there is a horizontal asymptote at y equals 1. Okay? All right? Step 3. Find the x-intercept by setting the numerator equal to 0. Okay, so we're going to add 2 to both sides. So x equals 2. So there is an x-intercept at x equals 2, or the point 2, 0. Step 4. We're going to graph graph f of x equals x minus 2 divided by x plus 2. Okay, so the first thing we need to do is graph the vertical asymptote. And I'll be right back. I need my black marker. All right. So our vertical asymptote is x equals okay. Now we have a horizontal asymptote at y equals 1. You want to graph your asymptotes first. Okay. Now we have an x-intercept at 2, 0. Okay. Now I'm going to go ahead and graph f of x. In yellow. Now, since you have the point here, we know it lies between these asymptotes, so your curve is here. Okay. Now we just need to find one point to the left here, and this is where I recommend using the inspire. Okay, so I'm going to go to on new document, add graph, press Control, divide x minus 2 divided by x plus 2. Okay, so we need to pick some point here. So we're going to press Control T, and we need a point to the left of negative 2. So we can use negative 3, negative 5. Okay, so negative 3 I'm sorry, let me check. I think I want to make sure I said it right. It's a positive 5. Well, almost made a mistake. It's a positive 5. So negative 3, 1, 2, 3, 4, 5. So that means our curve is right here. Okay, and the reason why I knew there was a mistake is it normally never have something here and here. Usually there's one at the top and one below. Okay, all right. So go ahead and finish up graphing that. All right. Now, step 5, find the domain. Domain is x is less than negative 2 or x is greater than negative 2. Set notation is x such that x is not equal to negative 2. Interval notation is from negative infinity to negative 2 or from negative 2 to infinity. Step 6, find the range. The range is y less than 1 or y is greater than 1. Set notation is y such that y does not equal 1. And interval notation is from negative infinity to 1 or from 1 to infinity. All right, let's take a look at question 8. All right. Select the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graph slant asymptote by dividing the numerator by the denominator. Also state the function's domain or range using inequality set notation and interval notation. If your graph indicates that the function has a maximum or minimum value, use a graphing calculator to find those values to the nearest 100 when finding the range. Okay, so you have f of x equals parentheses x minus 1 divided by x minus 2 times x plus 3. Step 1, find the vertical asymptote by setting the denominator equal to 0. Okay, so we're going to set x minus 2 equals 0 and x plus 3 equals 0 and solve. So that's x plus 2. So x equals 2. Subtract 3 from both sides. X equals negative 3. So there are vertical asymptotes at x equals 2 and x equals negative 3. All right, step 2, we're going to divide. Now, notice that I had to add the 0x squared to the x minus 1, so we have x squared x and constant, okay? Now, you ask yourself, well, what do you multiply x squared by to give you 0x squared? The answer to that is 0. So, there is a horizontal asymptote at y equals 0. Okay. Step 3, find the x-intercept by setting the numerator equal to 0. So we're going to add 1 to both sides, so x equals 1. So the x-intercept is x equals 1, or the point 1, 0. Okay? So step 4, we're going to graph f of x equals x minus 1 divided by x minus 2 times x plus 3. So first of all, we have vertical asymptotes at x equals negative 3. Okay, and x equals 2. Okay, and then we have a horizontal asymptote at y equals 0. Okay. Now, what I recommend doing is graphing this, okay, in our calculator. So I'm going to go to On, New Document, No, Add Graph, press Control, Divide, x minus 1. Oh, hold on. Before we do that, I almost forgot. We can graph this point 1, 0. Now, you can see it's on the asymptote, and that's unusual, but it does happen sometimes. Okay, so now we can go back here, x minus 1, parentheses x minus 2, parentheses x plus 2. Okay, now I'm going to delete that, and then we're going to press Control, Divide, Control T, and we need to point to the left of negative 3. Oh, I'm sorry, yep. Okay, and I want to make sure I type something in right. Give me a second. Tab, x minus 1 divided by x minus 2. So you want to be careful. I made a mistake in that this is x plus 2. It should be x plus 3. So you always want to go back and check to make sure you typed it in right, because every once in a while you can make a mistake typing in something. Okay, now Control T, and the reason why I knew a mistake, because I knew there should be an asymptote at negative 3. Okay, so I'm going to pick a point, and I'm going to see if I can find a good point to the left of negative 3. I can't find one. Okay, so the best thing to do is when you can't find a point, you see the curve is right here. So then we know that the curve is going to be right here. Okay. Now, it looks like, and we're trying to find a point between negative 3 and 2. We have 1, 0. And so these aren't really good points either. So again, you're looking at, well, you see the curve is going here, going through the x-intercept that way. Okay. So we know our curve goes like that, okay? And then you can see the curve is here, so then we know it's here. So sometimes when you can't use the points, you can just use what the graph looks like, okay? All right. All right. Step 5, find the domain. Domain is x is less than -3, or -3 is less than x when x is less than 2, or x is greater than 2. Set notation is x such that x is not equal to and x is not equal to -3. I haven't mentioned it, but these are the vertical asymptotes, okay? Interval notations from -infinity to -3, or from -3 to -2, or I'm sorry, +2, or 2 to infinity. Step 6, find the range. Since the inequality is -infinity to infinity, set notation is from -infinity to infinity, and interval notation is from -infinity to +infinity. All right. Go ahead and finish up with that. All right. Question number 9. Okay. Select the graph of the given rational function if the degree of the numerator is 1 more than the degree of the denominator. Find the graph's slant asymptote by dividing the numerator by the denominator. Excuse me. Also state the function's domain and range using inequality, set notation, and interval notation. If your graph indicates the function has a maximum or minimum values, use a graph and calculator to find the values to the nearest hundreds when finding the range. F of x equals parentheses x plus 1, parentheses x minus 1, divided by x plus 2. Step 1, find the vertical asymptote by setting the denominator equal to 0. Okay, so we said x plus 2 equals 0, so we're going to subtract 2 from both sides. Okay, so x equals -2. Okay, so there's a vertical asymptote at x equals -2. Okay, so now we're going to divide. Okay, so now we ask yourself, what do you multiply x squared by, or x by to give you x squared? The answer to that is x. Okay, so x times x is x squared. X times 2 is 2x. We subtract, so then that's -2x minus 1. Okay, now you ask yourself, what do you multiply 1x by to give you -2x? The answer to that is -2. Okay, so -2 times x is -2x. -2 times 2 is -4. Okay, so now we subtract, so that becomes positive, positive. Those cancel, you're left with 3. Okay, now in this case, you didn't have to go that far. You really, once you have x minus 2, you have the slant asymptote. So the line is y equals x minus 2 is a slant asymptote. All right. So, step 3, find the x-intercept by setting the numerator equal to 0. So, x plus 1 equals 0, x minus 1 equals 0. So, we're going to subtract 1 from both sides. So, x equals -1, and add 1 to both sides. X equals 1. Okay, so the x-intercept is x equals -1, or the point -1, 0. And there's actually 2, so it's also x equals 1. So the point 1, 0. Okay, so we're going to graph that. So first, we're going to graph the vertical asymptote at x equals -2. Okay, and then we have a slant asymptote at y equals x minus 2. So we start here and then we go up one to the right one, up one to the right one, up one to the right one. So this is y equals x minus 2. And that's technically 1 divided by 1. So that's where the slope up 1 to the right one comes from, and that's why we start at -2. Okay? Now, that is an asymptote, so we're going to dash the line. Okay? And then to find out where the curves are, we just need to graph this. Okay? So I'm going to do on, new document, no, add graph, press Control, divide. So I'm going to type in parentheses x plus 1, parentheses x minus 1 divided by x plus 2. Okay, and what you might have to do is go to Menu, Window Zoom, zoom out. Now, if that didn't work, then we can go to Menu, Window, right, Zoom Fit. Now, you can see that that really doesn't help you, right? So in this case, the Inspire really doesn't work. I mean, it shows you, but what I would probably do is I would probably go to Desmos and graph it. So sometimes Desmos is going to be a better choice for graphing, so let's try that. Okay, so we have parentheses x plus 1, parentheses x minus 1, divided by x plus 2. And you can see here that this kind of helps us get the curve a little better. So we see that curve is here and here. So we know that, and let me go back. So you can kind of see here's where the slant asymptote is. Okay, and it might help if you graphed y equals x minus 2. So you can see where the asymptote is. So you have here. And then if you graph also x equals -2, you can see it's a little easier. So it lies between the asymptotes here and here. Okay, so if I can get back to the page, we know our curve is right here. And here. Okay. All right. All right. So step 5, find the domain. Inequality notation is x such is x less than -2 or x is greater than -2. Set notation is x such that x does not equal -2, and interval notation is from -infinity to -2 or from -2 to infinity. Step 6, find the range. Now, to find the range, again, it's going to be helpful to go back to Desmos. And this is why, in this case, Desmos is better because now I can delete. We don't need these anymore. Okay, and we can use it there and there, and that's where you can get those values. Okay. All right. So the range is y less than -7.46 or y is greater than -0.54. And in set notation, it's y such that y is less than -7.46 or y is greater than -0.54. Interval notation is -infinity to -7.46 or from -0.54 to infinity. All right. Select the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graph slant asymptote by dividing the numerator by the denominator. Also state the function's domain and range using inequality set notation, interval notation. If your graph indicates that the function has a maximum or minimum values, use a graphing calculator to find those values to the nearest hundreds when finding the range. Okay, so we have f of x equals -3x, parentheses x minus 2 divided by x minus 2 times x plus 2. Find the whole by setting x minus 2 equals 0. And the reason why there's a whole is because this divides and becomes 1. So you're left with 3x okay, divided by x plus 2. Okay, so we're going to set x minus 2 equal to 0, so we add 2 to both sides. Okay, so x equals 2. Okay, but it's a whole is a point, so we need to plug 2 back into this function. So to find f of 2, we plug in 2 everywhere there's an x. And so then negative 3 times 2 is negative 6. Divided by 2 plus 2 is 4. Okay, so f of 2 equals, let's go ahead and find the decimal. So this is where the calculator is good to use on. You can go to calculate. We can press Control, divide, negative 6 divided by 4. Press Control, enter, negative 1.5. Okay, so the whole is at 2, comma, negative 1.5. Okay, now to find the vertical asymptote, we set the remaining denominator equal to 0. So we set x plus 2 equal to 0 and solve. So we subtract 2 from both sides. X equals negative 2. Okay, so there's a vertical asymptote at x equals negative 2. Okay. Step 3, divide. Negative 3, excuse me, parentheses x minus 2 divided by x minus 2 plus x plus 2. Okay. So to divide, what we need to do is simplify the numerator and denominator. Okay, so negative 3x times x is negative 3x squared. Negative 3x times negative 2 is a positive 6x. Okay, now we FOIL. X times x is x squared. X times 2 is plus 2x. Negative 2 times x is negative 2x. And then negative 2 times 2 is negative 4. Now, this becomes x squared. That becomes 0x minus 4. And then negative 3x squared plus 6x. But you also want to put plus 0, because if this has an x squared x constant, this needs to have x squared x and a constant. Okay? All right, so now we divide. You ask yourself, what do you multiply x squared by to give you negative 3x squared? Well, the answer to that is negative 3. Okay? Okay? So, there's a horizontal asymptote at y equals negative 3. Okay? Now, step 4, find the x-intercept by setting the numerator equal to 0. So we set that equal to 0, divide both sides by negative 3. Okay? Now, that divides becomes 1. X equals 0 divided by negative 3 is 0. Okay? So the x-intercept is 0, or the point 0, comma 0. Okay? So now let's go back. We want to graph the vertical asymptote first. Okay, so we have a vertical asymptote at x equals negative 2. Okay. All right. We also have a hole at 2, negative 1.5. And a hole is an open circle. Okay. Now we also know that we have a horizontal asymptote at y equals negative 3. Okay. Now let's go ahead and graph that. Okay. So I'm going to go on, new document, no, add graph, and then you're going to press Control divide, and then you're going to put in negative 3x divided by x plus 2. Okay. So now I'm going to press Control T. I need to find a point. Now we know we're going to go to the left of -2. So we can use the point -3, -9. Okay, so let's graph that point. Okay, so -3, -6, 7, 8, 9. So we know our point is somewhere here, okay? Because this would be -6, -7, -8, oh, -9. Actually, so I was off. Should actually be. Okay. So since our point is here, we know our curve is here, okay? Now, since we have the hole there, we know our curve is here, okay? And remember, that's an open circle, so it's not included there, okay? All right? Oh, sorry, this is y equals -3. All right, so go ahead and finish that graph up. All right. Step 6, find the domain. Inequality is x is less than -2, or -2 less than x less than 2, or x is greater than 2. Set notation is x such that x does not equal -2 and x does not equal 2. Interval notation is from -infinity to -2, or from -2 to 2, or from 2 to infinity. Step 7, find the range. Inequality notation is y less than -3, or y greater than -3. Set notation is y such that y does not equal -3. And interval notation is from -infinity to -3, or from -infinity to -3, or from -3 to infinity. All right. So select the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graphs of slant asymptote by dividing the numerator by the denominator. Also state the function's domain and range using inequalities, set notation, and interval notation. If your graph indicates that the function has a maximum or minimum values, use a graphing calculator to find those values with the nearest hundredth in finding the range. Okay, so we have f of x equals x squared plus x minus 6 divided by x minus 1. Step 1, find the vertical asymptote by setting the denominator equal to 0. So we said x minus 1 equal to 0, so we add 1 to both sides. So x equals 1. Okay. So there's a vertical asymptote at x equals 1. Step 2, divide. Okay. So we ask ourselves, well, what do you multiply x by to give you x squared? The answer to that is x, or 1x I should say. So now x times x is x squared. X times -1 is -1x. Now we subtract. Okay, so we subtract that becomes positive. So 1x and 1x is 2x. Bring down to -6. Okay. Now, you ask yourself, what do you multiply x by to give you 2x? The answer to that is +2. And you can stop because now we know the slant asymptote is y equals x plus 2, which I'm going to write that as 1 divided by 1 because that's your slope. It's going to go up 1 to the right 1. Okay. Okay. Step 3, find the x-intercept, and I should say x-intercepts, by setting the numerator equal to 0. So 2 parentheses equal to 0. So we have x and x. Okay. Now we ask ourselves, what do you multiply to give you -6 combined to be +1? Well, let's try -1 times 6 is -6. -1 plus 6 is 5. That doesn't work. Now let's try -2 times 3 is -6. -2 plus 3 is 1. So we have our -6 and 1. So that's x minus 2, x plus 3. Okay, so we said x minus 2 equal to 0, and x plus 3 equal to 0. Now you ask yourself, what do you subtract 2 to give you 0? The answer to that is x equals 2. And here, what do you add to 3 to give you 0? X equals -3. Okay, So the x-intercept is x equals -3. So the point is -3, 0. So let's go ahead and graph that point. So -3, 0 is -1, 2, 3, -3, 0. And then we have an x-intercept at x equals 2 of the point 2, 0, which is here. Okay. So now let's go back. We want to graph our vertical asymptote at x equals 1. Okay, and then we have a slant asymptote at y equals x plus 2. So we start at +2, and then we go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And then you go the opposite, down 1 to the left 1, 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 and so on. Okay, and then all you have to do is connect every other point to have the dashed line. And then here, it's real simple. We have our points, so we know our curve is right here and right here. Okay. And I almost forgot, this is y equals x plus 2. All right, go ahead and finish up the graph. All right, step 5, find the domain. Inequality is x is less than 1 or x is greater than 1. Set notation is x such that x does not equal 1. Interval notations from -infinity to 1 or 1 to infinity. Step 6, find the range. Inequality notations from -infinity to -infinity, and set notations from -infinity to +infinity, and interval notations from -infinity to +infinity. All right. Question 12. Select the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graph's slant asymptote by dividing the numerator by the denominator. Also state the function's domain and range using inequality or set notation, interval notation. If your graph indicates that the function has a maximum or minimum value, use a graphing calculator to find those values to the nearest 100 when finding the range. All right. So we have f of x equals 2x squared minus 4x divided by x squared plus 4x plus 4. Find the vertical asymptote by setting the denominator equal to 0. Okay, so we set the denominator equal to 0. We're going to factor and solve. Okay, we know that x and x makes x squared. Okay, so then we need to find out what number multiplies to give you 4 and combines to be 2x. Well, 1 times 4 is 4. 1 plus 4 is 5. That doesn't work. 2 times 2 is 4. 2 plus 2 is 4. Okay, so now we know that our factors are x plus 2, x plus 2. So we said x plus 2 equal to 0 and x plus 2 equal to 0. Well, we subtract 2 from both sides, so x equals -2. Subtract 2 from both sides, x equals -2. Okay, so there's a vertical asymptote at x equals -2. All right, step 2, divide. So now we ask ourselves, what do you multiply 1x squared to give you 2x squared? The answer to that is 2. So there's a horizontal asymptote at y equals 2. Okay. So find the x-intercept, and I should say x-intercepts, by setting the numerator equal to 0. Okay. So we're going to factor. Now we can divide a 2x from each term, so that's 2x, which leaves x minus 2 equal to 0. So we set 2x equal to 0 and x minus 2 equal to 0. Well, you ask yourself, well, what do you multiply 2 by to give you 0? The answer to that is x equals 0. So we have a point at 0, 0 for the x-intercept. Here we know that 2 minus 2 equals 0, so x equals 2. So we have a point x-intercept 2, 0. Okay, so let's go ahead and graph those points. Okay, so 0, 0 and 2, 0. Okay, now we know that we have a vertical asymptote at x equals -2. Okay, and we have a horizontal asymptote at y equals 2. Okay, so let's go ahead and graph this, and let's go ahead and use Desmos in this case. We've used the Inspire quite a few times, so delete here, and so then 2x squared minus 4x divided by, whoa, hold on, yep, x squared plus 4x plus 4. Okay, so you can see here, and here's a cool thing, is if I graph the asymptotes, they won't come out dashed, but I can graph x equals -2, and I can graph y equals 2. So you have, it shows you that our curve is here and here. Okay, so, and let me get back to there, sorry. Now, interestingly, you can see that it actually goes through and back up through that point, okay? So it goes through the 0, goes down, and goes up to the 2, 0, 0, okay? So we know our curve is right here. Okay, go back. And this is odd, it actually goes through the asymptote, but it happens sometimes. Okay, and sorry, we don't need that screen. So it actually goes through here, back up there. It's a unique case, but sometimes a line can actually go through the asymptote. Okay, all right. All right, question 12 of 15. Step 5. Find the domain. Inequality notation is x less than -2 or x is greater than -2. Set notation is x such that x does not equal -2. Interval notation is from -infinity to -2 or from -2 to infinity. Step 6. Find the range. Inequality notation is y greater than -2.25. And to find that number, we can use Desmos. Okay. And I think, well, we might need this, but let me go to on, new documents. No, let me just leave that on a blank screen so we don't get distracted by that. And let me go back to Desmos, and I can click off that point, and then you can go here, and you can see that's where the -0.25 comes from, okay? And then y is greater than -0.25, and then interval notation is from -0.25 to infinity, okay? All right. Question 13. Enter a rational function to model the situation. Enter a reasonable domain and range for the function using set notation, then select the graph of the function and answer the question. A basketball team has won 16 games out of 24 games played. For winning percentage expressed as a decimal of 16 divided by 24 is approximately 0.667. How many consecutive games must a team win to raise its winning percentage to 0.75? Step 1. Let W be the number of consecutive games to be won. Then the total number of games W on its is a function T of W equals 16 plus W, and the total number of games played is the function T of W equals 24 plus W. Therefore, the rational function that gives a team's winning percentage is P of W equals the won games equals 16 plus W divided by the games played, 24 plus W. The main irrational function is W such that W is greater than or equal to 0 and W is a whole number. Step 3. Since the value of P of x started at 0.667 and approaches 1 as W increases without bound, the range is P such that 0.667 less than P less than 1. Okay. All right. Now, step 4, graph y equals, so we're going to graph y equals 16. Now, you can't use w, so you have to use 16 plus x divided by 24 plus x. Now, it wants to know how many consecutive games must the team win to raise its winning percentage of 0.75. So you're going to graph y equals 0.75. Okay, so now let's graph this line in yellow, and we can graph this line in black. Okay, so 0.75, which is right here. Okay, and I think Desmos is probably our best decision for here. So I'm going to X out this, X out that, and let's just X out that and start over. So I'm going to press divide, and then that's 16 plus x. Oh, if I can type this in right, 16 plus x divided by 24 plus x. Okay. Oh, where'd that 5 come from? X. Okay. And then I'm going to graph 0.75. Okay. Now, in this case, you can see that Desmos really didn't work very well to find that. Okay. So I'm going to say goodbye to Desmos. And then I'm going to come here to the Inspire. So we're going to go to Add Graph. I'm going to graph Control, divide 16 plus x divided by 24 plus x. Enter, and then press Tab, 0.75. Okay. Now I want to go to Menu, View, Grid, Line Grid. I'm going to delete these equations to get that out of the way, and I want to make my window make it look like the one on the paper, and it's going to be under assignment. So I'm going to go to Menu, Window Zoom, Window Settings. Now the X min I'm going to make 0, the X max I'm going to make 11, the scale they're counting by ones. Now the Y min is 0 and the Y max is 1, and we're going to count by 0.1. Press OK. Now we want to find the point of intersection, so we're going to go to Menu, Window Zoom, Analyze Graph, Intersection, click, drag across, and ta-da, we find out the value is 8. Okay, so, and in essence, really, trying to graph that here, you can see that it starts at 0.1, 2, 3, 4, 5, 6, between 7 and 8. You could try to graph this, and really what happens is it goes, here's our point of intersection. So it goes through there like that. So it's not very good to try to graph it by hand. Really, it's better on the calculator. But nonetheless, you can see that here you find that the number of consecutive games that the team must win is 8 games. Okay. All right. Let's take a look at the next question. All right. Now, question 14 of 15. Enter a rational function to model the situation. Enter a reasonable domain and range for the function using set notation. Then select the graph of the function. Enter the question. So far, his season, a baseball player has had 85 hits and 295 times at bat, for a batting average of 85 divided by 295, which is approximately 0.288, which is an okay batting average. It's not as good as our Wildcat baseball players' batting averages. They bat usually 0.5, 0.75 batting averages, but nonetheless, the player must, or I should say, want to raise his batting average to 0.300. Okay, so step 1, let H be the number of consecutive hits, then the total number of hits is a function t equals 85 plus w, and the total number of times at bat is a function t equals 295 plus h. Therefore, the rational function that gives a player's batting average is 85 plus h divided by 295 plus h. Step 2. The domain of the rational function is h such that h is greater than or equal to 0 and w is a whole number. Step 3. Since the value of a of h starts at 0.288 and approaches 1 as h increases without bound, the range is a such that 0.288 is less than a and a is less than 1. Okay. Now, we want to graph 85 plus h divided by 295 plus h and y equals 0.300. Now, technically that's right to write h, but we're going to change h to x. Okay, when we graph in our calculator, okay? All right, so graphing, you can graph it by hand, but honestly, I recommend going here in new document, no, add graph, press Control divide. We're going to graph 85 plus x divided by 295 plus x. Press enter. I'm going to delete this. I'm going to go to menu, view, grid, line grid. Okay. And then I'm going to go press tab, and we want to graph 0.300. Now, we want to adjust our window. So we want to go to menu, window zoom, window settings, and we're going to graph, we know the x min is 0. We're going to go to 11. Scale is 1. Y minimum 0. And max is 1. And we're counting by 0.1. Okay? So press OK. Now, we're going to go to menu, window zoom, analyze graph, intersection, click, drag across, and you can see here that the answer is 5. So, here you find the number of consecutive hits needed to bring the player's batting average to .300 is 5 hits. Okay. All right, last question. Okay, select the statement that applies a rational function, and this is divide. Okay, so the correct answers are the domain of the function is x such that x does not equal -3 and x does not equal 4. And you get that, okay, by setting x plus x squared minus 1x minus 12 equal to 0. We're going to factor. Now, we need to find out what numbers multiply to give you -12 and combine to be -1. Well, the answer to that is x plus 3 and x minus 4, because 3 times -4 is -12, and 3 minus 4 is -1. So we said x plus 3 equal to 0, x minus 4 equal to 0. Subtract 3 from both sides, x equals -3. Add 4 to both sides, x equals 4. Okay? That's where we get the -3 and 4. Okay? The range is from -infinity to positive infinity. The graph of the function has a horizontal asymptote at y equals 0. And we find that by dividing. So we're going to divide x minus 2. And actually, hold on. I don't have enough space right here, so I'm going to have to come down here. Now, we need to write x minus 2 is actually 0x squared minus 1x minus 2 divided into x squared minus 1x minus 12. Okay? And then basically, you're going to get 0 here because nothing goes here. So that's where you get the y equals 0. And then the asymptotes come from x equals -3 and x equals 4. Okay? And hold on. Whoa. I'm almost made a mistake. And the mistake I made, and be careful, don't make the mistake I made, is I put this in the divisor spot. It should be actually this. So x squared minus 1x minus 12 divided by 0x squared plus 1x minus 2. I apologize for almost leaving the video with the mistake, but I'm going to correct it here. So now you ask yourself, what do you multiply 1x squared by to give you 0x squared? The answer to that is 0. Okay? And that's where you get the y equals 0. Okay? And then the asymptotes come from x equals -3, x equals 4. Okay? All right, so if you would, go and finish your assignment and have a wonderful Wildcat day. And I almost forgot, you noticed that I was coughing in the video, which it was a safe environment because I was in a closed room by myself. But now I'm finishing the video, and I'm going to depart my room, and I'm going to be around people. So I'm going to put my mask on, and I'm going to stay 6 feet apart to protect others. Okay, so with that, have a safe and wonderful Wildcat day.